Hey everybody, I had a great question from a student about the voltage loop rule, and I want to talk about it for a bit. So let's say you had a circuit with a battery and a group of resistors. Let's put 3 in series right here. A reminder about the voltage rule. It says whatever voltage you gain in a circuit, you have to lose. Whatever potential energy these charges get from the battery gets used up throughout the entire circuit. That's always the case as it turns into heat across these resistors. So the question was, could voltage be negative? And absolutely. In a battery, if you see a 9-volt battery, that's because potential at one end is positive 4.5 and at the other end is negative 4.5. And that accounts for a voltage gain of positive 9 volts. But the reason why we set the potential or the voltage at 0 right here is just because physicists like to make problems easier when they can. Either way, it accounts for a plus 9 volt gain. It's kind of like in problems where we did in November, we would do a roller coaster. And even though the ground might be here, if we were dealing with a problem that said, what's the speed of the roller coaster maybe here, we might set y equals 0 here to make this problem a little easier. And that's the same rationale. We just set a place where v equals 0. And it doesn't matter, because whatever you go up, either way you're going up plus 9 volts across this circuit. And then throughout all 3 of these resistors, you have to go down to 9 volts. The math might work out where if they're all the same strength, you drop 3 volts, 3 volts, 3 volts. That would happen if it was 30 ohms, 30 ohms, and 30 ohms. Or 5 ohms, 5 ohms, and 5 ohms. Those would all be 3-volt drops. Across a circuit, if it was 3 resistors in series, all in a row, where they were different strengths, where this was 10 ohms, this was, I don't know, 10 ohms again, and this was 70 ohms, there we go. And this is a 9-volt battery. We would gain plus 9 volts, and then the math would work out where this would be 1-volt drop, this would be 1-volt drop, and this would be a 7-volt drop. It's 7 times the resistance, so 7 times the voltage drop. In parallel, if I set these up, it doesn't matter what their resistances are, they always have the same voltage drop. That if this is plus 9 volts, this one has to have a 9-volt drop, this one has to have a 9-volt drop, and this one has to have a 9-volt drop, because they're each the only resistor in their entire loop. So it doesn't matter if it's 70 ohms, 10 ohms, and 10 ohms again, they both have 9-volt drops. And if you simplify the circuits to figure out the currents in each of them, you can highlight that more, but this is just about the voltage law in this video. And the next question was, well, what about a short circuit? Where does the voltage drop happen there? If this is a 9-volt battery, where does the drop happen? Well, in reality, it happens across the wires themselves. Usually we ignore their resistance because it's so small. But remember, a wire has a resistivity. If it's copper, it's really small, on the order of 10 to the negative 8th or something. It has a length and it has a cross-sectional area. And the resistance of these wires in here might be 0.001 ohms or something, but it's not 0. So that's where your voltage drop actually happens across all of those. And according to Ohm's law, I equals delta V over R. This 9 volts is now over 0.0001 ohms, and that's what makes your current super big. So a short circuit is an infinite current because everything will have a little bit of resistance in these wires we're talking about. but a short circuit just means a lot of current, enough to start a fire. So that is more about the voltage law. In these problems, to figure out these actual voltages up here, again, simplify the circuits to find their equivalent resistance, use the voltage law for just one resistor, and then you figure out your currents. I can post another video about that if you have questions about where I got these individual voltages from. All right, happy learning.